Bonjour Benoît. Est-ce que ça marche d'ailleurs?
Salut, est-ce que tu
Attention,
m'entends?
s'il te plaît.
Ouais. Attends, je vais se calmer. On est en train d'installer ici. On nous entend? Bonjour Benoît.
Pour moi, c'est bon, ouais.
Ok, cool. C'est pas très fort par contre avec la chouette, on entend bien? Ouais. On est en train d'installer ici.
Normalement, ouais.
Hop. On va installer un truc pour que les gens entendent mieux et voient mieux.
Tu avais imprimé tous les papiers, tu m'avais dit?
Non.
Merde.
Je sais, j'ai pas le temps.
Ah oui, mais tu m'avais dit ça, donc je l'ai
Mais
pas fait.
j'ai un mail où ça va vite.
Oui, mais c'est vrai.
J'ai réuni tout dans un mail.
Il y a besoin absolument des papiers maintenant, Catherine, qu'est-ce qu'on fasse? Ouais, non, je me doute. Il m'avait dit qu'il les imprimait, en fait, il l'a pas fait. C'est grave de ne pas les avoir. On peut faire le rapport sur une consigne sur une intelligence, en général. Il y a Jacopo aussi, on est trois. Il est varié.
Benjamin,
Benjamin, il a la licence, il est à Circle. Ah oui, par mail, sinon. Ouais. Ah oui, on pourra délibérer à lire. Ah bah oui. Ouais. Donc, si tu les as, tu peux les envoyer soit à moi, soit à Catherine.
ouais, je les envoie maintenant ou à la fin?
Ouais, bah vas-y.
Ok.
Comme ça, on les a.
Je le fais tout de suite. Ouais, j'ai tout réuni dans un mail.
T'as une rallonge?
Ouais.
Là. Ouais.
Voilà.
Ensuite,
Ouais, vas-y, on
tu l'as branché USB là, ouais.
Oui.
Normalement, dans le Zoom. Bonjour Benoît.
Là, on a, ouais, comment on voit dans le Zoom ici?
Normalement, là, attends.
On peut voir à la limite sur YouTube.
Il faut choisir le son aussi.
Alors, je vous entends plus, je sais pas si c'est normal.
Bah non, c'est pas normal.
Merde, on mute. Mute. Tu ne l'entends pas?
Benoît?
Pardon. Est-ce qu'il faut que j'aie un accord, un Excel?
Ouais, vas-y, ouais, essaye. Ouais, et maintenant?
Est-ce que tu nous entends? Non. Et on...
Là, tu nous entends?
Speaker, c'est pas ça? Echo cancelling. Sinon, on met mon truc pour parler et...
Ouais, mais c'est
là.
pour entendre les membres
Ah,
du
oui.
jury, en fait, c'est mieux. Select speaker.
Ouais, switch to
Là,
phone as well.
ouais, pourtant, quand on parle, il
Oui,
a l'air de
il
nous
nous
capter.
entend, ouais.
Benoît, tu nous entends? Ouais. Benoît, tu nous entends maintenant ou pas? Allô? Pourquoi ils n'entendent plus rien?
Je sais pas du tout.
Tout à l'heure, ils m'entendaient?
Ouais, mais c'était... Oui, tout à l'heure, il entendait, je crois.
Il nous faut Christophe. Oui. Allô, allô? Ok, il va pouvoir nous aider, Benjamin.
C'est Benjamin?
Oui.
Attends, là, t'as mis.
Benjamin, tu nous entends ou pas?
Non, il nous entend pas.
Je vous entends, oui, je vous entends. Vous m'entendez?
Ouais.
C'est pas nous le problème.
Par contre, Benoît avait l'air de pas nous entendre. Alors, je sais pas pourquoi.
Ouais, c'est bizarre, hier ça marchait bien pourtant.
Du coup, si Benjamin nous entend, c'est...
Ouais, c'est pas... Tu peux peut-être
C'est
lui
pas
mettre
nous.
un message par chat.
Chat.
Niveau de la vidéo, là, s'il est debout, ça, Benjamin, c'est bien ou c'est comment?
C'est bien là. Faudra éventuellement déplacer la chouette au moment des questions pour la placer un peu plus au centre, parce que sinon on n'entendra pas le jury, ou alors il faut que le jury présent par le soir.
En tout cas, pour la présentation, c'est mieux comme ça, peut-être.
Ouais, non, c'est nettement mieux parce qu'hier, c'était trop.
Hier, on voyait que ces gens, ouais.
Ouais.
Et Benjamin, tu vois du coup bien l'écran ou pas avec le partage?
Parfaitement, ouais, je vois tes mails et tes réunions en 2 jours. Ça réduit ta
Et il reste ça à gérer, Thomas.
Attends, comment? Voilà. Hop,
T'as une prise HDMI.
ouais. Et juste, du coup, Benoît ne nous entend pas.
Ah.
Ah, t'as changé de speaker?
Je sais pas. Benjamin, tu nous entends toujours?
Parfaitement.
Ah oui, c'est là-bas. Alors ça, c'est peut-être un peu trop, non? Bon, c'est pas très grave. Vas-y, parle, Benjamin.
Ouais, je parle d'homme. Vous m'entendez?
Ouais, sur les haut-parleurs de la salle, mais bon,
Oh, c'est pas mal.
c'est pas grave. Faut juste comprendre bien les questions.
Bah, fais ce qu'il y a de mieux au point de vue de la qualité. Enfin, il faut que tu entendes bien les questions, quoi. Après, ça, c'est le plus important.
Je pense que c'est toi qui choisis. Hein.
Ouais, mais c'est pas grave, sinon on peut laisser.
Ouais, faut résoudre le problème de Benoît qui t'entend pas.
Il m'a pas vu mon message, je sais pas. Je sais pas.
Et savoir ce que deviennent Ramzato et Sarah.
Ouais.
Allô? Est-ce que vous m'entendez?
Oui, on t'entend, Benoît, tu nous entends ou pas?
Ok, j'ai des petits problèmes avec le son, mais ça devrait être bon.
Là, tu nous entends maintenant?
Que tu nous entends, Benoît?
Et vous m'entendez?
Ouais,
Est-ce que c'est mieux là?
oui. Mais est-ce que toi, tu nous entends?
Oui.
Ok.
Ok, c'est bon.
C'est toujours bon là?
Oui.
J'avais eu, oui.
Est-ce que tu avais eu les membres du jury avec les délégations?
J'ai eu la délégation de Oriol et de Sarah et pas eu celle de Ronaldo.
D'accord.
Il avait mis accepter sur l'invitation. Du coup, tu disais, il faut que je me tienne où pour que ce soit bien?
Voilà, comme j'étais, là, tu vois, mais normalement, elle suit, là, je crois que c'est.
Elle me suit?
C'est fait pour.
D'accord.
Si c'était comme ça, normalement.
Ouais, ça marche parfaitement. C'est bon.
Ça marche parfaitement, mais magique.
Super.
Ouais.
Est-ce que vous m'entendez là?
Ouais. Très bien.
Ok, merci. Alors hier, on avait du mal à entendre les membres du jury qui étaient en présentiel.
Ouais.
Je ne sais pas s'ils peuvent se rapprocher. Enfin, si vous pouvez leur donner le micro, par exemple, quand ils parlent, ce serait le top.
Ouais, on essaiera de rapprocher la chouette.
Ah.
Merci.
C'est bon pour la lumière, là,
Ok, il nous manque Sarah, du coup.
Sarah et Marc Aurélien, ouais. Ouais, ça doit être.
So we're missing Marc Aurelio.
Ouais, vous n'avez pas une nouvelle de Marc Aurélien?
mais qui avait mis accepté sur l'événement.
Ouais. On va essayer de voir si Auriel.
Hello.
Hi. Hello.
Hello.
Do you hear me well?
Yes, loud and clear. Hello. Good morning.
Good morning. So we're only missing one last member of the jury, and we can start.
Wonderful.
It's in the invitation.
Et Auriel, t'as réussi à parler avec lui,
Bah, j'ai l'impression.
et il t'a répondu, sinon?
It's Jacopo. It's a Zoom in the invitation. Yeah, there's a Zoom link, and it's. Hmm? You want me to send her the link?
Yeah, I just sent her the one that was in the email, but there's a Google Doc.
Hmm? Let me. On the event, maybe. On the event, she should just click and.
Oh.
So, Sarah.
T'as activé ton channel YouTube, sinon?
Ouais, normalement, tu peux regarder sur ma chaîne.
Ouais, je l'ai.
Try to connect the Zoom just to see. I don't know. It's working? Huh? It's in the invitation, all the logins. And...
You can connect with your browser.
I don't know. I know they updated Zoom yesterday. So
I mean, that's why we asking you to log in via.
Like, Benjamin, did you need like any account for Zoom or any other stuff and the link and the
Sorry?
page? Did you need anything to where to connect?
No, it's okay. No, I had no troubles. No trouble.
Sarah is trying to connect apparently, but it's. And are you via the app or the browser? But is anyone via the browser or everyone via an app?
Via an app for myself.
Up.
Yeah, maybe we need the app. I don't know.
Okay, I will need the browsers.
Hmm?
Asking you
And Sylvain Sylvain used the browser and it's fine. So
So she's saying she needs us for email and password. How did this?
yeah, I just explained it. So it's working for Sylvain as well. Maybe she needs just a Zoom account. I don't know.
This. Okay. Maybe.
She needs to ask questions. Oh, she's there.
Oh, yeah, okay.
Hi, Sarah. Is it working? Sarah, do you hear us?
Yes.
Hi, good morning.
Sorry, everybody. Never happened to me to have these kind of problems with Zoom. Sorry for the delay.
It's fine. They just updated, I think. Okay, so I can start. Vous voulez introduire? Vous introduisez? Allez-y. Je vais essayer de voir juste si tout le monde pour voir s'ils entendent.
Can you hear me? Hola.
The president of the jury is going to speak. Can you confirm you can hear us properly?
Yeah, it's okay. She has to speak loudly, but as she's done it, it was okay, at least for me.
So it's my pleasure. I'm Captain Flasher. It's my pleasure to be to present this PhD defense. So Thomas Scialom will have 45 minutes presentation, and then we will have quite a lot of questions because the jury is a bit large. So we have Sarah Tonelli. She's a director of research at Bruno Kessler's Foundation. Then Benoît Favre is professor at Aix-Marseille University. Then we'll go for the examinator. Marc Aurelio Manzato from DeepMind. And after Oriol Vinyals from Google DeepMind also. And the director, you have 3 PhD directors. And I will conclude some questions. Okay? So the floor is yours.
Thank you. So hi, everyone. Today I'm going to present you for my PhD defense, natural language generation with reinforcement learning. So natural language generation encompasses important societal applications. For instance, machine translations could lead to connecting the world beyond languages. Abstractive summarization at the era of information overload is pretty important to follow the news, keep track of science, chit-chat dialogue, or even image captioning, which could have direct use cases like giving some sense of what objects are nearby for instance, blind people. But what is very interesting with natural language generation subject is that it also brings some important scientific questions. Like for machine translation, it means that a machine is able to understand different languages and translate them. Abstractive summarization requires some skills like to hierarchicalize information, learns what to what is important or not. Image captioning, it means that the machine is able to map different modalities, image and text. And finally, chit-chat dialogue is arguably at the core of what is strong AI, like within, for instance, the well-known Turing test, which is a test to distinguish, if a machine passes the Turing test, it means that it's undistinguishable from a human. So because of these two axes, scientific and societal questions, natural language generation is a very interesting topic. Nowadays, main standard architectures are based on encoder-decoder for sequence-to-sequence generation. Until 17th, it was based on recurrent neural networks at STM group. And from 17th, now 5 years ago, and the transformer, attention is all you need, all the architectures are based now on that, which is a mainstream architecture. And the main progress it brings is parallelism, which enables to, at large scale, process data, which leads us to, when you have access to large scale processing, you can leverage on self-supervision. The second concept that made a revolution for natural language generation and beyond. The idea is, given a text corpus, just raw text from the web, you can predict the future, which in text means the next tokens. Or you can also have the bidirectional mask, which means you just mask random tokens in the middle of a text, and you try to guess, the machine is trained to guess what is a token. So this combines transformer and self-supervision has led to dramatic improvements in natural language processing and beyond. For instance, here is the results on the GLUE benchmark, one of the main benchmark for NLP. It stands for Global Language Understanding. And you can see that quickly, thanks to from BERT and the next iterations of transformers and combined with self-supervision, it leads to results even better than human performance. But so GLUE, the U means understanding. And so these are only like classification tasks, understanding tasks. So there's still a lot of limitations for generation tasks. And outputs are going to have some hallucinations, repetitions, and poor output quality. So if I had to summarize a framework for training, inference, evaluation, and all the pipeline for natural language generation, there's first the training phase. You have some training data, input and outputs. The model do a forward pass. So basically it predicts the text and have a backward pass given the human ground truth reference. Basically here, the model, the weights are updated with gradient descent to learn to imitate what a human will do. Then once the model is trained, you have the decoding phase. At this phase, you have new data the model never seen, and it's there to predict. So there's only a forward pass, which leads us to a text that is generated. For instance, a translation when you use Google Translation. And so we can evaluate our models. But because there's a mismatch between training and decoding, and I will just come very soon to this mismatch, this leads to some, when we evaluate the models, hallucinations, repetitions. So one of the main ideas to mitigate this mismatch is to leverage the evaluation and fade it somehow during the training phase. So this can be done, for instance, with reinforcement learning or other techniques that I will develop. How the training is done? So via an algorithm, standard algorithm is teacher forcing. Teacher forcing is a maximum likelihood estimation where the model is conditioned on the ground truth. For instance, here, let's say that it's summarization tasks. So X is your source document, document on which you want to generate a summary. And so YT are the tokens we want to generate. And Y star, the reference token from the ground truth. So we will basically train the model to predict, to generate YT, knowing condition on X, the source document, and all the tokens before T. Let's take a concrete example. So here we want to, there's a ground truth, which is two people running, etc. Let's compare the training and the decoding stage. we initiate with a start of sentence. The model generates 2. And the model, so its condition fed with 2. Then the model outputs birds. So here, birds doesn't correspond to the ground truth, right? The ground truth was people. And so here, at training stage, because it's teacher forcing and it's conditioned on the ground truth, you will feed to the model, you will condition it on people. But at decoding stage, it would be cheating to have access to the reference. You can't. And so you will use instead birds, which is what the model just generated. And so this is what is referred as the exposure bias, a mismatch between training and inference. And this bias is known to have to be the cause of several flaws in natural language generation. While the text would increase in terms of length, you can have much more and more of this mismatch. And so you can have a divergence, so the errors accumulate. And so this is an example in practice from a professor forcing paper of the exposure bias for handwriting generation. You can see that at the middle of the generation, the model made clearly a mistake, and it cannot recover from it. So an LG model are subject to this exposure bias. There's a too strong focus on the ground truth sequences, while many others could be correct, actually. And it does not allow to consider specific decoding, which I will come back later. But for instance, at decoding time, you can use sampling, beam search, nucleus sampling, while we just focus here on standard sampling for the model. And there's a lack of a sequence level loss because the optimization within teacher forcing is at a token level. In consequence, generated texts are degenerate and prone to repetitions. So a solution to mitigate this gap between training and inference is the reinforcement learning. So reinforcement learning is an alternative to the teacher forcing algorithm, where the idea is to maximize the reward of the generated text. So let's say you have a model that sample generates a summary. Then the summary is scored within any scorer and eventually compared to the ground truth. This can be standard metrics, like which I will define later, like rouge, bleu, for summarization or translation. And so those automatic metrics will score the generated summary. And this score can be used as a reward, such that the model maximizes this reward. So the reward is used for training, while the sequence sampled is used for inference. And because the reward is scoring the entire sequence, you can see how this reinforcement learning paradigm can mitigate the mismatch between training and inference within teacher forcing. So reinforcement learning has been applied already for natural language generation. For instance, machine translation using bleu as a reward, which is a standard metric for translation, or by Romain Paulus on abstractive summarization using rouge, which is a standard metric for summarization. So now the question is, to what extent those metrics, and I'm not spoiling, but they don't reflect well human judgment. So, because if you want to maximize the reward, in the end, you can maximize this reward, but what you want really is to maximize the quality of the output. So now the question is, would this reward correlate well with human judgment? So those metrics, bleu, rouge, they are n-grams metrics. They are basic. The idea is to compare an evaluated text, what the model just generated, with respect to a human reference, summary written by a journalist, a translation made by a professional translator. And so there's a count of co-occurrences of n-grams. N-grams is like, for instance, standardly 4 with an n equal 4 for translation. And these metrics suffer from several flaws. Let's take just a concrete example to see it. So here the source for translation is "Ce métier est très intéressant," which translates in English, "This job is very interesting." Now, a model generated "This job is very interesting." So blue is a metric born between 0 and 1, 1 being perfect. Obviously, the evaluated text here and the reference are exactly similar. So you have a perfect blue of 1. Good. Now, we just change a word, and this work is very interesting, which is arguably a good translation. Here, the blue will be 0 because there's no 4 grams that match the reference. Okay, and let's change the last word. The job is very boring, which now the meaning is completely opposite to the source text. And here, this blue will still be 0.5, which is better than the second translation, where the meaning is completely the opposite. So you can see how these metrics have a lot of flaws. To improve with respect to exact match similarity, there's some new metrics like BERT score that leverage neural representation of transformer plus self-supervision models pre-trained. It's a smoother similarity, but still it's a token level similarity. And token level similarity has a lot of flaws as well. Like it requires an alignment between the two texts we are comparing. And the issue is that more than one output for generative tasks can be correct. There's more than one translation, and even so for summarization. Given a source document, there's a lot of different summaries that could be correct. And so those metrics, because they're token level, they're very greedy in references. And it has been shown that while we provide less and less references, the correlation decreases with human judgment. The intuition here is that there's an extremely large surface of possible outputs for one source text. And so when we provide only one single reference, the model might generate something correct but different. And as I just illustrated before, you will have a very poor score. This is actually quite problematic. Why now with large-scale data sets, we often provide only one single reference. And so those metrics poorly reflect human judgment. Let's see this in practice. Here is a sum-eval study, one of the largest of its kind for summarization, where so you have CNN Daily Mail news articles and paired with their summary written by expert journalists. And so for this study, Alex Fabry, so he generated with 11 different systems summaries. He asked human expert annotators, not mechanical typers, but expert annotators, to score them on 2 dimensions, consistency and relevance. And so for each example of generated summary, we have the human score for consistency, for relevance, and all the automatic score for the different metrics like rouge, bleu, or BERT score. So there's more than 1,500 examples here, and we can compute the correlation. Here is reported the person coefficient in base 100. You can see that for consistency, it's roughly no more than 0.2 coefficient, and for relevance, 0.35. That's quite low. One thing important also to emphasize is that there's 11 references for this correlation. And in practice, people report scores using only one single reference on this data set. The reason is there are 11 references that Alex Fabry asked the annotators to write 10 additional summaries to compute the correlations. So let's see what the correlation now comes when we have only access to one single reference, which is real case. It drops by half, and you have for consistency 0.1, which is pretty low, and for relevance, less than 0.2. So too long didn't read, evaluation in natural language generation remains an open research question. So blue and rouge has low correlation with human judgment. Back to reinforcement learning to improve generation. What happens when they are used as a reward? We improve the metrics, but at the cost of a lower output quality. And this is what has happened when Romain Paulus trained a model on summarization using rouge as a reward within a reinforcement learning scheme. You can see that rouge improved with respect to teacher forcing, as expected, but at the cost of less readability. So to have better rewards, we need better natural language generation metrics. Now, let's present a new kind of metrics based on question answering and generation. What will make a good summary? Only a short text that contains all the important information of its source document. And based on this definition, let's get a model that you have the source document and the summary generated. You can have a model that generates all the relevant questions. then you can ask this question on the two texts, the source and the summary, compare the answers. And if two answers are similar, it means that the information is preserved. Otherwise, there's an issue, an hallucination, or information missing. So based on this idea, we developed SummaQA, where the idea is to generate all the possible questions on the source document. Because of this, then you ask them on the evaluated text, and so it's recall-oriented. It's a measure of what the amount of information preserved from the source document into the summary. Extending our idea and kind of the other side of the coin, Alex Wong developed QUAGs, where it is to generate all the questions, but this time on the evaluated text, and ask them on the source document. So this time it's precision-oriented, as it is a measure of all the information present in the evaluated text. Are they correct or not? Are they matching the source document? How those two metrics correlate on our SumEval study? It seems to be very promising results. QUAGs almost getting state-of-the-art for consistency, and SummaQA for relevance, pretty good results. Important to note that those two metrics don't require any references, because you're just comparing a source text to its evaluated text. As expected, SummaQA correlates better for relevance, it's recall-oriented, and QUAGs for consistency, it's precision-oriented. Can we do better? So we propose QuestEval, where the idea is to unify the two previous, QUAGs and SumQA, precision and recall-oriented. And also integrate a query weighter, where the idea is, so for SummaQA, we generated all the possible questions in the source document, but arguably summarization is also about selecting important information and not anecdotal code information. And so we train a weighter. I can come back to that later for more details, to select the important questions or not. So overall, this is how displayed QuestEval. And how QuestEval performs on our SumEval study. Well, it dramatically improved all the correlation. For consistency, we're now almost at 0.5, while still not requiring any references. And for relevance, we are at 0.4. Before going back to reinforcement learning and maybe using this new metric for reinforcement learning, some perspective. First of all, it's toward an explainable, like interpretable metric. It's not just a score like rouge or blue. Let's take a concrete example. You have a source document. This is the embarrassing moment a Buckingham Palace guard slipped on a manhole during the changing of guard. Here, our question generation model generated where was the changing of guard held. The QA system asking on the source document, say Buckingham Palace. On the evaluated text, Buckingham Palace. So you can see that it's correct. It will improve the score for this evaluated text, and there's no hallucination. But now we have an hallucination. It's not at sometimes at Buckingham Palace, but the generated text said, the evaluated summary, at St. James Palace. This is an hallucination. And so asking on that, the question answering system will say St. James Palace. And you can see that there's a mismatch. So you have a fine-grained automatic annotation about hallucinations. And another example, so you could just have an information that is not present in the evaluated text. In that case, our QA model is able to just say unanswerable, because it was trained on Squad V2, which provides also some unanswerable questions. So QuestEval is also a sequence level metric to measure content similarity, compared to bleu, bear score, rouge that are token level. This has important consequences. This is actually the reason why it is referenceless, because you don't have any requirement anymore for comparing at a token level. You can now compare directly the source text to its evaluated text. Here is an illustration of this, providing the correlation, providing less and less references from 11 to 1. You can see that QuestEval is stationary, while all the other metrics progressively drop. And it also means actually that QuestEval is even multimodal. Well, you can generate questions on images or tables and ask them on the caption. And so you can evaluate image captioning or table captioning, which we did in 2 papers this year at CMLP. And so do for multilingual, because there's a lot of morphological languages that are not based at a token level, like agglutinative languages, etc. And so token level metrics don't fit all the languages. But again, you can ask questions and answer them in any languages. And so by nature, Costeval is multilingual. To that, you need a question answering systems, which is multilingual, which we provide in a paper as well as in NLP, and an end-to-end adaptation, which we just released. So now back to question-based rewards. Now that we have a better metrics, can we improve the generation as well? So we did that for SUMMIT QA. And you can see that overall, so the baseline is teacher forcing. When we reinforce on rouge, you decrease with respect to the relevance. But when it's on our metric, you increase the relevance. It's a slight gain, but still a gain. That's the beauty of open source. We haven't done that for Costeval, but at MNLP already someone did it. And the results seems that it leads to even further improvement. So two pre-trained models that just improve over BART and Pegasus, when they are reinforced on BART QA and Pegasus QA, the reinforcement metric reward is Costeval. It seems to lead to more factual scenarios. So that's quite good, and those metrics are better than rouge, bleu, and leads to improvements with reinforcement learning, but they're still biased. They don't have a perfect correlation, and also they are static. Well, it's the same metric that is applied and provide a reward during all the training of the model. Because of that, the generator can take advantage of the metrics weaknesses during training. And so the longer you train, the many steps during training, the more it can diverge actually from a good output. And so we need unbiased and dynamic reward so that can learn to adapt automatically to the generator. Toward automatic and dynamic rewards, naturally you have discriminators. So a classifier that is trained to distinguish between human and machine outputs. This is also known as generative adversarial networks. It's important to note that for text, as opposed to images, you cannot backpropagate the gradient from the discriminator. So you need to use reinforcement learning. This is due to the discrete nature of text. And so the standard framework for language GANs is reinforcement learning, where the reward is a discriminator that keeps trained as well as the generator is trained. Unfortunately, because of this discrete nature, reinforcement learning, language GAN are known to fall short compared to teacher forcing alternative. But it's also interesting to see that discriminators are highly accurate to distinguish between human and machine text, more than 90% accuracy. So the question is, how can we leverage on discriminators' performance at decoding time, maybe just using a frozen generator, or even better at training time, like language GANs. So discriminator first for decoding, which is what we first tried. It might be because language GANs are not working well. We tried that first because you don't require to train to keep training the generator. And so let's just see the standard way to decode for natural language generation: sampling, where you select a token one by one, or beam search, where basically here the idea is to approximate the argmax of in terms of probabilities given by the generator for a sequence. And at each step, you will re-rank all the beams, the k-beams, with respect to the generator probability. So you can see that as like a beam search or even sampling, leveraging only a generator probability as a decoding strategy with only single leg. They, in practice, require a lot of heuristics to work and not so well with hallucination repetitions, like top K, top P nucleus, length penalty, avoiding 3-gram repetitions. And so what about decoding with a generator probabilities, but also a discriminator probability? So because discriminators are so good, why not leveraging on them? So we propose DAS for discriminative adversarial search. It's a new decoding method where the idea is to, at each step of the beam search, instead of re-ranking based only on the generator probability, leverage also the discriminator probability. Here the generator is frozen. We don't require any heuristics, and yet it's state-of-the-art for summarization. In a concurrent work in the paper Residual Energy-Based Model for Text, they use the same exact idea, but instead of doing re-ranking at each step of a beam search, they did for sampling. So they sample n sequences and re-rank them with an energy model, which is the discriminator. And also they get state-of-the-art results for this time unconditional natural language generation. There's still one limitation with these approaches. They're left to right decoding. So a lot of time you have kind of a dead end where models like the discriminator know that all these sequences are not doesn't sound human, but because they are step-by-step left to right, you cannot recover from that, get back to a previous step, and try to generate something else. So we propose co-op MCTS, a decoding strategy based on Monte Carlo research. So here is for Monte Carlo research, you have first a selection where you get until a node. A node here is a token. Then you have the expansion phase, eventually a simulation, which is optional. And for the simulation, it's like going to the end of the game, which means going to the end of the generation. And finally, the back propagation, where the result of the game is actually the result of the generation, a discriminator score on the final sequence. So this is a concrete example of co-op MCTS in practice. Here the task is question generation based on a context where the task is to generate a question for which the answer will be the condition answer, Super Bowl. From step 1 to step 16, which corresponds to kind of like beam search or DAS, left to right, the model generated something. What was the name of the game that would have been known as Super Bowl? Arguably, Super Bowl is not a very good answer to this kind of question. And thanks to, so with left to right strategies, you will just be in a dead end here. Thanks to co-op MCTS, you could, the model decided to go back to another leaf and starting again from how, finally generating how is called the American football game that determines the NFL champions, which is arguably a better question. So despite providing some good results, decoding based on discriminator and generator, the decoding only with the discriminators are limited. Here the generator is frozen, which means that you will remain, the generation is constrained to the generator's comfort zone because you cannot explore all the graph with respect to the discriminator. And so to go one step further, you need to unfreeze the generator, which leads us to the GAN framework. Language GANs. Why language GANs are falling short? Well, one intuition is that for language GANs via reinforcement learning, the exploration is based on sampling with the default policy of the generator, p theta. And so this is done with a temperature T equal 1, which is a default temperature. This doesn't correspond to exactly what we do at decoding stage when we use nucleus sampling or beam search. And so it's very likely with T equal 1 to sample from the tail distribution, which is actually what tried to prevent nucleus sampling. And so it leads to unstructured sequences and training instability. So we proposed call-GAN, timing language GANs with cautious sampling strategies. The idea is to use an alternative exploration strategy than p theta with a default T equal 1, where we will lower the temperature or even use nucleus sampling to explore. It leads to more structured sample sequences, as we just observed for decoding. And so it stabilizes the discriminator and leads to a smoother learning dynamic. So because we have an alternative exploration strategy to have a non-biased policy gradient, we use important sampling. And it gets a state-of-the-art result on 3 generation tasks: summarization, question generation, and unconditional text generation. So we have good discriminator at decoding stage. We have call-GAN, which is the first GAN that works compared to teacher forcing for language. Can we combine the two ideas? Which we did in self-GAN, to beam or not to beam. That is a question of cooperation for language GAN. The idea is the expert learning framework. In expert learning, you have an apprentice and an expert, and the apprentice try to imitate the expert. In our setup, the apprentice is a generator we try to improve. The expert is a cooperative decoding based on the generator and the discriminator. And so because cooperative decoding is arguably better than leveraging generator and discriminator is better than generator only, the expert is better than the apprentice by nature. And so it ensures an improvement, which we observed. So basically, the discriminator is used here only to drive the cooperation, so to drive the exploration. And it never provides a direct reward, as we just use the cooperative decoding samples to further train on it the generator. So it's it can be seen as an alternative solution toward sparsity of the reward, which helps to stabilize the training. And so we experimented in several combinations using some MLE, which is teacher forcing, with different decoding, DAS, which I presented before, DAS global, which corresponds to the energy-based sampling, similar to DAS, COP MCTS, with different GANs, call GAN, set GAN. Overall, I won't go into the detail of all the numbers here, but the conclusion is that COP MCTS always compares favorably for doing both when it is used for learning and also at decoding stage. And self-GAN outperforms both MLE and previous GANs, including COS-GAN. There's one limitation, which is that there's no theoretical convergence guarantees here. So we propose generative cooperative networks, GCN, where the idea is to combine co-GAN and self-GAN. For co-GAN, we had importance sampling, while we don't have for self-GAN. For GCN, we use not importance sampling, but weighted importance sampling. And for the decoding, the expression stage for co-GAN, we had a generator only, while self-GAN leverage on both cooperative decoding, generator and discriminator. And so for GCN, we use both cooperative. So it leads us to these pullback layer objectives. And you can see that, so here the ZT can be acting as a scale at each step. And so it can be seen as like an automatic scheduler, which is an interesting finding in the paper. Here you have the training dynamic. So at each steps, each epoch of the training, with so a scheduler and a standard wedge GAN, which leads to a small decrease. Again, using like co-GAN with nucleus sampling, it's slightly improved. And as expected, like we just showed before, GAN with MCTS, which leads to further improvement. But now all those GANs and all the one I presented so far are using a scheduler. If we remove the scheduler, it happens actually that it completely diverges and all the metrics are decreasing. And when now we use GCN, you can see that this Z acts like a naturally implicit scheduler, and without even any scheduler, you can lead to even better further improvements. So now in terms of conclusion and future work. For conclusions, we saw that at training time, leveraging a discriminator is a promising direction. For language GANs, even at inference time to empower the decoding strategy, and both can be combined. In terms of evaluation, question-based metrics pave the way toward better evaluations. They are more accurate, factual, they are interpretable, they don't require any references, which means that you can even use them at inference time in production without any ground truth references. And they are multimodal, multilingual, and multitask by nature. In future work, so we would like to apply self-GAN to other sequential domains, other domains where you cannot, by the nature of these domains, you could not backpropagate the gradients of GANs. We wanted to get some theoretical convergence proofs for self-GAN, which we did so this year at ICML. For QuestEval, we'd like to explore also more in depth its interpretable aspect and how, in terms of human-machine interaction, this could be leveraged. And eventually, you leverage QuestEval at inference time as a re-ranking strategy, just like we used the discriminator. Could this lead to more factual content? And finally, at the era of large language models like Chinchilla, Gopher, Palm, it will be important to, so first of all, measure for those models the exposure bias and factual inconsistencies. Are those still real problems for those models or not? And if so, it means that it's more than ever important problems, because more and more tasks with these generative models are framed as, even NLU tasks are framed as natural language generation tasks, which leads to more expressiveness, but maybe more, maybe subject to this exposure bias and factual inconsistencies. And finally, if these methods works for those models, it's there's open question about the scalability, because it's something to have a method that works for few millions, eventually 1 billion parameters. For 500 billion parameters, it's another story. And so I will finish and on these contributions. And thank you very much.
So thank you for respecting the time you had. So now we start with the questions. And I think we should start with the rapporteur. And we often start with the rapporteur, which is further away, which is Sarah Tonelli. Sarah, it's your turn.
Sarah, you hear?
Yes, yes. Hi, thank you. Thanks for the presentation and for your work. I really enjoyed reading it. I think it's an outstanding contribution to NLG. And I mean, this last slide shows how much work you put in your thesis and how many top-tier publications you were able to publish. So there isn't much to add. So I have a couple of high-level questions. So the first one is if you can comment on the robustness of QuestEval. So if you, I mean, the main evaluation was done on a news corpus. I've seen that you did some experiments also with social media. So if you can elaborate on that and I don't know if there are some limitations that can be addressed about this aspect.
Sure. Thank you, Sarah. So I will start that first. I will distinguish between QuestEval framework and QuestEval implementation. In terms of frameworks, you could imagine any kind of question generator, question answering systems, even humans. And this is actually a method that has shown a lot of robustness for evaluating summarization, which is a very hard task. In terms of QuestEval as it with its current implementation based on T5 models, it's imperfect, but I think it's still quite robust, and I will give some results there. So we used it and measured it on summarization, the corpus I just presented here, but then we applied it in other tasks, like for instance, machine text simplification. Mm-hmm. And it directly obtains state-of-the-art results way beyond BERT score Bleu Rouge without any modifications or adaptations, just not a waiter, because in simplification, you don't want to remove questions, like not as opposed to summarization. We then applied it to other tasks, so image captioning, table to text, and 2D data set there. And even we've seen, so we needed a question generator on multimodal inputs like tables or text, so that we just use a synthetic way to generate, so synthetic data, train a question generator on that and a question answer on that. And even with this, we obtain state-of-the-art results with no modification of the metrics. Still, one thing that remains to me unanswered is all those correlations are measured on a lot of different outputs, and often those outputs are provided by systems that are not all state-of-the-art. And so I really wonder if we took only, for instance, the last Palm model, which is the last state-of-the-art, and which is better also than T5. What happens if on only those outputs we measure the correlation? Would it give the same kind of correlations? Maybe not. That's the main limitation, I would say.
Okay, thank you. And I have another question. So something that you didn't mention in the presentation, but was in the thesis, the fact that at some points human evaluators were involved, both experts, and you used also Amazon Mechanical Turk to evaluate for relevance and readability, I think. Do you think, what's your idea about the quality? How can we get, let's say, homogeneous evaluations of these dimensions from humans, given that they are so important to evaluate systems? But to me, as a linguist, I have a linguistic background, so I also know that it's very difficult to guide people to judge in the same way relevance, readability, and dimensions like this. What's your feeling?
Yeah, I think it's a very important question. And one interesting work in this direction that emphasize what you just said is so reinforcement learning papers from OpenAI on summarization. In a first paper they published, they use reinforcement learning to improve summarization. They fine-tune GPT. It was GPT-2. And what they do is that the reward signal is not from any automatic metric, but from human evaluation. And it happens that it didn't perform that well because human evaluation was broad, not well framed. And so basically it was a sparse reward for the model. They then worked quite a lot to improve the evaluation framework to define more clearly the tasks. And doing that, they published a second paper where this time, so the same exact framework, but just a better evaluation framework for the humans to reward the system, it leads to way better results. So I think it totally emphasizes what you just said about the importance to define very well evaluation. I know that it depends of also the domains. Like for instance, on machine translation, it seems that they now converge toward a single score from humans adequacy. On summarization, it's much more difficult. On the other hand, it's much more difficult to evaluate summarization. Like translation at a sentence level is easier. So I think one of the important aspects I noted during all these experiments and for having good human evaluation is to have, so first of all, experts of the domain, people that are at least trained a bit on this, not, for instance, mechanical turkers. And a second aspect is to define a very clear protocols that don't lead to too much doubt.
Okay, I have a couple more questions, but maybe I keep them for the end of the discussion if we have more time. So I'm fine for the moment.
Okay, thank you, Sarah. So now we start with Benoit.
Can you hear me?
Yes.
Yeah, so first I'd like to congratulate you for your thesis. I think your contribution is very broad and it's a very good scientific quality. As Sarah said, I think your last slide is shows the breadth of your contribution. It's really very nice. I liked the documents, the thesis documents, although I think you could have been a bit more pedagogical in some aspects, maybe a bit more synthetic in some other aspects. Anyway, I was really delighted to see that you put all the pedagogical elements in your presentation, which was really nice to follow. So I have a few. I actually have many questions, but I'm only going to ask a few. So the first one is about the factoring order. So so basically the basic premise of almost all generation methods is to generate texts left to right, or maybe from past to future, if you think of right to left writing. And so your proposal is to extend that factoring order, or to still continue in this factoring order, but to look at whole sequences and then be able to come back to the start of the generation. And there's been some effort in recent work in generating in different orders than the left to right order. So I was wondering if you have tried to explore this avenue, and if you had maybe like generating first, I don't know, like following a dependency tree, or generating first the easy parts of the sentence and so on. And what would be the impact of such generation orders on the approaches you propose?
Yeah, I think it's a very interesting direction. We tried something which is kind of connected, but without very good results at one moment. Which was, there's two ways to do that. One is to start the generation itself, not left to right, as you suggested. The other one is to kind of provide a proofread mechanism somehow, which will start a generation and then fix the issues, come back, kind of like a human will do from a draft. We tried something leveraging on BERT bidirectionality to improve the generation, but without really good results. The idea was to basically, once we generated the text, check if BERT could not, like, instead of a token, like we can mask it, generate something better than BERT. We didn't get good result there, but I saw some other papers that did. So probably there's something interesting to pursue there. And I'm not aware of all the literature in not left to right generation, but I remember some papers claiming that you could even get the same scores generating right to left or from the middle, or basically the order won't matter that much. And I think I agree with you. It suggests that it might be even like it might be under efficient what we're doing, and we might find a better way to start from easiest part and then complete and like. But so then the question is, will you do that at a token level space, or even like at the latent space? And which is also why like people try to do with GANs, with language GANs, where they try to provide discriminator in the latent space. But I haven't seen any good positive results there in this direction.
Yeah, okay, thanks. Yeah, I agree with you. So to go to your quest eval proposition, so if you look at some summarization as a kind of prototypical task in generation, in summarization you need to generalize. So you need, for instance, to use several facts from the input, and then only outputs a single fact that covers all those facts, or for maybe several entities, and you replace those entities with an entity which encompasses for all of them. So this is one kind of generalization, and there's another kind of generalization, which is that you need to use world knowledge in order to generate the text. And so those two aspects are kind of different views of the same problem, and I think that it's a problem that cannot be grasped directly by question answering. And so I was wondering if you had some ideas on how this could be handled by your quest eval approach, and how it can be and like how what is its impacts in evaluation?
Yeah, I think one of the direction that could be used to face that is you could still leverage QuestEval, but not asking and generating all the question on a source document and the evaluated text, but also leveraging some external documents that could be, for instance, retrieved, which leads to like generative plus retrieval models, which seems very promising in this kind of context, like retro, for instance, recently. And in that way, you could imagine a model that, so you will retrieve external information in addition of the source document, and you could combine, so you will need to define a bit different metric, but on the same kind of principles, you could leverage questions on all of them and ask and see if the information corresponds given the source document or eventually external source of information. That could be a way, I would say, to integrate QuestEval in a framework that will leverage also external information.
Yeah, that's a good idea. And so still on QuestEval, so you probably know that question answering systems make mistakes, so there is a kind of so first they make mistake, and the question is how to handle them, and then the second aspect is that the exposure bias you were talking about in the beginning is actually also applicable to the question answering problematic, because the question answering system has never seen generated text at training time. So I was wondering also if you had some ideas about that.
So yeah, I will just say, as I said to Sarah before, there's a distinction between the framework and the implementation. And we even wanted, but we didn't have the time or the money to do that, to compute QuestEval score using humans expert to generate another questions, which could be seen as an upper bound. This would allow us to see the difference between the limitation of current question answering systems and the actual potential of the framework. And so right now, we are focusing only with QuestEval on factuality, and so factual answers, and train on squad. There's no hallucination for this kind of question answering systems. It's a span that is it's question answering systems that are extractive. So we don't have this issue of hallucination. But I agree with you. It's also very interesting to see that if we extend the paradigm to, I don't know, we could imagine a QuestEval to measure even not factual summaries, but philosophical summaries, or like a summary of a book. And for this kind of evaluation, you will need not a factual question answering system, but more like an abstractive system. And then you come back to the issue of natural language generation in the exposure bias. But so for now, for only factual constancy, I don't think there's any issue with this hallucination for question answering systems, although there's still some issues with question answering itself. It's not perfect. Still, because it's way easier than generative and don't suffer actually from the exposure bias, in average and over all the corpus, it provides two good correlations.
Yeah, you're right. Okay, thanks. So in your GAN contribution, you have discriminator, and I was wondering what is the generality of this discriminator? Can you train it on one generator or against one generator and then apply it to other generators and kind of factor the training? Also, you compared to using questions, the discriminator loses the ability for explainability, and I was wondering if this explainability could be reintroduced when performing the generation.
Yeah, thank you for asking. I think it's so we discussed that in I think it's in ColdGAN, or yes, probably in ColdGAN paper, where basically what we call the discriminator over specialization. Basically, what we discovered is that, so if you train a discriminator on even just one generator, but where the decoding were happening with a specific decoding strategy, like nucleus sampling or beam search or different temperatures, T1, T0, which is greedy decoding. You train a discriminator, so on only one of those modes, the discriminator will be extremely good as we saw for this exact mode, but will completely fail to predict, to have a good accuracy outside of this mode. Concretely, if you train it on a sampling with T equal 1, the discriminator is very good on this distribution mode. But then if you provide to the discriminator some outputs from generator with greedy decoding, temperature equals 0, the discriminator will then think it's human-like. And so this is what we think is that this is kind of an hyper specialization of the discriminator, which is also what explains the good performance of the discriminator compared to the generator. And eventually, maybe my intuition is that if we train a discriminator on all the possible modes of the generator, on all the vocabulary, all the distribution of the language, maybe it will just result as a generator and nothing better, because it will have a good sense of all the language distribution, but won't be any more specialized on something. So I hope it answers your question.
And so, about the explainability aspects.
About this, sorry?
Explainability, that you lose explainability when you have this.
Yeah, absolutely. So, first of all, I will emphasize, which I didn't mention yet, that discriminators, the discriminator we use are sequential discriminators. So they provide a score for your text to sound human or machine generated at a subsequence level, from the first token, then the first 2 tokens, etc. So we can see the change of prediction between human-like and machine-like at the exact step it happens, first of all. But still, I totally agree with you. There's no more explainability there, which is not that important maybe during training. But this is also why those metrics couldn't be used for evaluation, factual evaluation. And I think it's also a good thing to have a reward that is not used to evaluate the models in the end. And so if we have in one side discriminators to improve generation, and on the other side, better metrics like QuestEval to actually evaluate, it provides, I think, a much more robust framework to train and evaluate models.
Yeah, I like that point. So just one last question. Could you comment on the computational cost of the different approaches that you have proposed?
Yeah, so I don't recall the exact numbers, but MCTS compared to sampling is like 2 orders of magnitudes more. So it's quite a lot. Like, for instance, I know for a model I'm currently using, which has like 30 billion parameters, so still quite less than the last big models. We have something like at advanced time with 40 giga GPU, few seconds for generating 500 tokens. So 2 orders of magnitudes more than that is very expensive.
Okay, so you think it's a trade-off between computation and performance, or we can find a trade-off?
I mean, it depends on the context, mostly. Because on the other hand, if it's only during training to train better models, that then will be used at inference time, even with sampling. Like a model trained with CELGAN or GCN with a cooperative strategies, even decoded with sampling only and not cooperative, leads to better results than doing teacher forcing. And so if it's a matter of having a very accurate and reliable inference at the cost of, so the training will cost more, but at inference time, it won't change anything. I mean, in the end, if we use a model a lot, the inference, the training might becomes cheaper with respect to the total cost. So it's also, I would say, a question of context.
Yeah, okay. So thank you for your answers, and I leave the floor.
Thank you, Benoit.
Okay, thank you, Benoit. So now we go with the examinator. So we start with Marco Aurelio Ronzato.
I'm here. So congratulations. It is really outstanding work. And both from the technical point of view, and I can say because I've been working a little bit on these topics, and what you have done is technically very is non-trivial, and it is has technical depth. So you had done really strong contributions in this field, and I'm honored to be part of this committee. My questions follow a little bit Benoit's previous question. So let's start with the last one that he asked about the scalability and computational complexity. In a way, what you have when you train is a computational budget, right? So I don't know, you have 1 week that you spend on your GPU to train your language model. And it's not quite true in practice that, well, you know, you spend more time training and then at inference time, you know, what matters is inference time, because at training time, what you could do is you could spend your compute by seeing more data, for instance. So you could do, and we know that these models don't quite overfit, right? So you feed them with more data, they improve. So the question is, should you spend your compute seeing less data, but getting better signal, versus should you see more data, but have a poorer learning signal? Do you have any comments on this?
Yeah, I think it's a very good point. If you have access to more data, right now, more data will be more beneficial, I think, than those methods. On the other hand, I would say that, first of all those methods running on more data are widely used from a long time now, and they are mainstream. So here, there's to me a signal that we could find a way, even better ways and improvement of the methods I presented there, that could be more robust, computational efficient, so we could get the best of both worlds. And just to comment on the fact that models are overfitting and we can always provide model, I think this starts to be less the case with, for instance, Palm, which now is, we don't have any, there's not enough token available on the web to train it even further. So we are at a stage where this could actually not be true anymore for this kind of models.
Okay. And since you touched on Palm and those alike models, how do you feel that as we scale up, there is more problem with inconsistencies, exposure bias, and so on and so forth? Or do you think that how much relevant are these problems in the area of these large-scale language models or language generators?
Yeah. So my feeling is that, well, until very recently, the actual outputs of the model was so bad that we couldn't even measure these aspects of hallucination factor consistency. Like, it means not, if the text generated is not even enough fluent to be understood, then measuring factor consistency was very silly. Now that we have so good models, we are focusing on these problems more. It doesn't mean they are happening more than before. I actually think that it's less the case. And that's not something that can, I mean, I had some discussion with people using Palm, for instance. It seems, and that's not any experiment I can report or any numbers, but they try to break it down, to break it with some hallucinations, trying to ask the model to distinguish if it's an hallucination or not. They couldn't manage to do that. So from those observations, it seems that those models are less and less hallucinating. But this is also an important stage, because at this point, if this model seems to be more and more reliable, they start to be used in actual production. And we start to be confident about them. And so this is at this stage where it's much more important than ever to measure their factual consistency. So just as an example, like Google just published Minerva, which is fine-tuned on archive and LaTeX papers that can do some solving math problems. And in the main papers and the blog post, one of the problems that the model solves, which is like showing the ability of the problem as a positive example for which the model solves the problem, has actually a flaw, and the resolution of the problem is not correct. And the model didn't, the humans actually didn't saw that because they trusted the model. So because the models are better, we are trusting them more. And so the problem is even more important than ever, I think.
So I must say that I very much agree with you. And I really like your intellectual honesty, also in the way that you stated your response. And in fact, I think that you're very much right that particularly when you put these systems in production, the worst case scenario that happens in the long tail really matters. So yeah. I think I'll conclude with one last question that is minor regarding your evaluation, the Quest Eval evaluation. So it relies on a Q&A system, right? But these systems, we have pretty good systems for English, right? But how about for other languages? And I know that you mentioned that you did evaluations also on multilingual systems. I was just curious to hear how, where you got your Q&A to compute your metric.
Sure. So, yeah, we have a data set in English only, let's say SQUAD, Stanford Question Answering Data Set. We have a multilingual pre-trained model, BERT multilingual, T5 multilingual, which is basically trained in a self-supervised way, but not in English document only, but any languages. All the languages provided during training. What happens that, so the model is not really good for multilingual generation, but is very good for multilingual understanding. If you take this pre-trained model, which is multilingual, fine-tune it on SQUAD English, and then provide a context and a question in French or Italian, and the model would actually understand the text because the encoder remains kind of close to the initial state as opposed to the decoder. And so because of that, the model is very good at zero-shot multilingual prediction. What we did in the first paper is to even improve the scores, because there's still a gap between English and other languages performance, is to generate multilingual questions. So you train a multilingual question generator, train on a translation of SQUAD. Then you have synthetic question and answering pairs. And fine-tuning the model on those synthetic data in addition of SQUAD leads to even better results. And in the last paper we did, actually, so one of the main issue is still how can you in zero-shot generate multilingual questions? Actually, what we did to do to that is to not generate questions. Instead, to consider closed form questions. You have a sentence. Louis XIV was a king of France. Instead of generating the question, who was Louis XIV? You can just, Louis XIV was mask, and so mask this, which becomes a question, a closed form question. And that way, this method applies to any languages. And so that's the way we finally did.
Very nice. That's fantastic, Thomas. So thank you. I'm done.
Okay, thank you, Antonio. Now goes over your vignettes.
Yeah, hello, can you hear me?
Yeah.
Great. So yeah, first of all, thanks for the invitation. It's been great to see this all this work unfold. It includes so many of my favorite machine learning and NLP topics. So it's been a blast to kind of have a very distilled, condensed reminder of the field and how exciting it is. I think I agree with everyone that clearly the output from your thesis and beyond is outstanding. And I particularly like these ideas of using machine learning models to improve our metrics. I enjoyed a lot the Questival section in particular. But before I ask a few questions, many have been asked that are great, but I have I'm not sure if by accident or I will receive these or maybe it filtered, but I actually didn't get the full manuscript. So I've seen the presentation only. So actually some feedback that I don't know if others would agree, but I think you did a very good job at the introduction, at presenting, natural language generation, and then explaining the RL framework and the challenge of the metrics. And then I like also how Questival was presented and so on. Then I felt the rest was a bit too much in like little time. And since maybe in practice the presentation is something you will repeat and refine, maybe the feedback is maybe try to dive a bit deeper into maybe the generative discriminative setting or something else rather than presenting. I mean, you clearly didn't present everything because this list is very long, but I would recommend maybe trying to unpack a bit more and cover a bit less, especially in a kind of 45 minutes presentation. So that's feedback not on the manuscript but on the talk. And then actually many of the questions I have, as I said, have been asked, but I have one. Maybe since we had a good discussion, I had the kind of training speed in mind. My first question is it's very basic, right? Is yes, like we can ignore teacher forcing and decode and try to re-rank or learn reward functions and so on. I wonder what's your experience with the kind of tricks that I usually see when these works appear, which is you need to do some amount of pre-training with teacher forcing, which is the most efficient for various reasons, for sequence models at least. Or if you don't need any pre-training and you just do the MCTS training or anything other or any of these other methods you presented, or if you combine them. I'm curious to what do you think is a good kind of pipeline for creating these models with efficiency in mind as well?
Yeah, I think it's a very interesting question. For what we did standardly is to initiate with teacher so pre-training, self-supervision, then teacher forcing, and then language guides. Although we did ablations not using teacher forcing, and from scratch, but because also of self-supervision, it works. Still, in terms of efficiency, I won't recommend it. It's better to initialize a model with something which is already close to the weights we would like to.
Great. Yeah, I guess, based on some previous questions, and I guess there's an interesting trade-off to study here, probably in terms of scaling laws and so on, and lots to do in the field, which is obviously very, very exciting. So the question I wasn't super clear to me what was the once you presented Questival, you mentioned well this is kind of static metric. So two sub questions is, you said that because it's a static, you found a way that maybe the metric was cheated by the generator. I'm curious if you got any insights, because once you see you create a metric, you make it the goal, you see how it fails. Maybe there are some insights that you could introduce to improve it. So curious if you did any of that. And then more generally, I would like to see maybe what exactly was the setting from the discriminator side of things. What did you fine tune or what did you adjust there? It wasn't very clear from the talk. I was still wrapping my head around Questival when you presented that.
So yeah, about Questival. So your question again is for Questival?
If you train to hill climb it, you will get some very good scores. But how is the model doing that? What is the failure mode that you didn't anticipate when you thought about the metric?
I see. Yeah. So I think it's it leads to the root cause is that we're using deep learning models as question answering and generation systems. Because of that, they're kind of classifiers in the end. And so they are subject to adversarial attacks. And so once the model finds an adversarial attack that works, it will just learn basically to generate those texts that for which the model will always provide the answer, but it doesn't rely to something a good output. I don't think it will be the case actually for if we would use like humans as question answering systems or like a model that is not subject to adversarial attacks. And so for this reason, it doesn't provide directly a way to also improve Questeval finding its failure modes. It's much more about finding its, if you use Questeval on a model that hasn't been exposed to Questeval to improve, there's no reason why it would find directly its failure modes. And I guess it will even depend on the question answering system that has been trained for that. So it doesn't provide now a suggestion for all the systems that we could use for Questeval.
Yeah, so to be clear, then the failure mode, did you observe some sort of weird way in which the summary was created that that then made a question that was, I don't know, trivial or so on, and then the score was very high?
Yeah, absolutely, definitely. Like it's for Rouge, we observe, like for instance, that the model used to put a lot of dots at the end of the generated text. Seems to improve Rouge. For Questeval, there was some very weird outputs and also long outputs, because the longer you generate, the more probably you will find an answer. We might find some way to compensate that, to balance it with like a length penalty or some like custom reward, but instead we decided to explore automatic rewards discriminators.
Got it. Okay, yeah, the length penalty was going to be a question, like, but there's been a few questions, so I'll keep it a bit shorter. Cool. So I guess my more broader question on this section is, so when you train the reward model to not be fooled in these ways, what you're doing is you take the pre-trained question generator and just fine tune it so that it's not fooled. Is that what you do?
So you mean for Questeval?
Yeah, no, well, for when you do the kind of the GAN approach with Questeval.
No, so we did for the GAN, we used, so we did two things. We did one, which is not a GAN, with Questeval as a reward or some accurate. And as second stage, we use GAN, where this time it's a discriminator. So which one are you mentioning? The one where we reinforce with the question generator, or with the discriminator?
Yeah, I mean, I thought what you could have done, maybe that's future work, is you take your question generator, which is your discriminator in the GAN setting, and then you can adjust it so that these weird questions or making it longer and so on doesn't work anymore.
I see. Yeah, I mean.
So maybe that comes next. It's fine. The next paper of this list is okay.
Yeah.
Cool. And then very last question. So towards the end, and this relates to the multilingual question from others here as well. So at the end, you have these translation systems, and I saw that you're showing blue as well as the metric. And yeah, just curious to how long do you think until some maybe question answering base metric for translation takes off? You kind of answered this last, but I was curious whether you had tried anything, even if it's preliminary, on that, on not summarization, but for instance, machine translation.
So it's current works. We have tried it for summarization. It seems to work. We have tried it on multilingual simplification, which seems to work as well. And for translation, we are trying it. One of the main difficulties so it seems to have good correlations, not state-of-the-art correlations with the recent metrics. One of the things is, so the last version of the metrics, which use a mask, this actually is kind of a bidirectional setting of the recent BART score, which is left to right. And so that way we should even improve BART score because we have access not only to the left, but also to the right. So we should have a way. And this is also a good way to see like a convergence connection between language modeling metrics like BART score and question answering metrics. And one of the main difficulties for translation we also see is that the main evaluation, all the evaluations are mostly done on adequacy, which is kind of an average. And it might perform better for factual consistency, for instance, than fluency. And so evaluating it and reporting correlations on an average just leads to less SNIL, I guess.
Cool, great. Yeah, okay, cool. Yeah, that's all I have. I mean, great questions were asked already, so I'll yield the floor as well. Congrats, this is very nice and lots of interesting topics here at play together. So congrats on a very, I know, technically difficult, but very successful set of projects and research direction.
Thank you. So now we go with the director de recherche. And I propose to start for the further story, Benjamin Pivovarsky.
Yeah. Okay, so first I would like to congratulate Thomas for all the 3 years we spent working together. It's been really a pleasure, and well, I'm still impressed by the list of contributions as it stands, as everybody, I guess. Then I was very excited by the topic when we started writing it. So it's a pleasure to see that not only you mastered, well, you followed what we roughly set as guidelines for the thesis, but you went much further and you explored a lot of things with a lot of energy. And I think you deserve all these, I mean, all the comments and all the publication you had, because you put so much energy in making those system works, and they are not, well, as it has been said, it's very hard to make them work. And when we started to go along the GAN direction, we started slowly, and I think it was slowly, but it's what triggered all the works that you did on improving the GANs and making them work, and it was really a challenge, and I'm very happy that you succeeded in it. And well, overall, I have to thank you again for all the discussion we had. It was very enlightening, and I very much appreciated all this time. And well, we are sorry you have to go away, but sometimes, well, it's we hope the best for your future and the following path you will follow. That's all for me.
Thank you, Benjamin. So now with Jacopo.
So yeah, I totally agree with Benjamin, and it was a privilege to work with you over these few years. So I thank you for the amount of work you put in. It's impressive over there. I can only congratulate you and wish you the best for the next steps of your career. And I'm really curious to see what's going to be your next paper.
Thank you. And finally, Silva, Jean-Pierre.
Okay, as my colleagues, I have no special questions. Really strong congrats to family. First of all, I wanted to thank Benjamin for inviting me to supervise you during this thesis that I really enjoyed to supervise with Jacopo. And yes, it was a very fruitful collaboration. We really progressed together. I feel like progressed a lot with you. And I remember that anecdotes and things that were very funny, very nice with you. This thesis, especially at night at the beginning of your thesis, where we finished one of your first papers in a bar, rewriting everything a few hours before the deadline, with a lot of drunk people around us, and very curious about what you are doing here. And yeah, it was the starting of a very long series of very nice contributions. Maybe that's the key of PhD. When you can write in that condition, you can do everything. more seriously, I think that you have an amazing ability to make these models, large-scale model work, and you have very good intuitions about what can work, what cannot, and sometimes you are the one that say to us, no, that's impossible. Maybe sometimes it works, right? And yeah, it was very nice to work with you, but very comfortable to have some discussions about direction. And on one day and some few days after, you come back with everything working, or sometimes not working, but with an in-depth analysis about what is happening and what we can do to overcome the issues. And that was very nice. Everything was easy with you. You have very large knowledge of this very active field and very good intuition. I will say that. Okay, I wish you the best for the future, and I hope we can still collaborate. I have still things to do with you. I want to explain to you again. Thanks for
Okay, thank you. So on the last one, first of all, your research area is not exactly my research area. That's why I really appreciated so much the pedagogical you put in your introduction. It was so clear, you set up to the frame, the ideas, the questions. It was really great. I would really appreciate it. I'm sorry, I would have two small questions. And one is, I think we must have already mentioned it. So, for example, in the examples you show, it starts with it's embarrassing. Okay, these examples, it's slide 28. When I mentioned something that about the different type of question you have depending on the content, and you said, yeah, we could use different, I forgot the word you use, but maybe framework or set of questions. However, here is a very fact-based text, but it has any opinions on embarrassing. How can you capture this fact? Because it could be important depending on the type of information you want to carry in the summary. That could be important information. So how can, and you could, for example, nice emoticons. I mean, could that help, or do you need further types of analysis of that?
So just to specify, so is your question about how do we discuss is asking a question about embarrassing is important or not?
That is one point. However, how can you add that to your summary?
Right.
Because if you don't add it, you make the assumption it's not interesting.
Right.
That's important.
So I would say it's a question of what's the policy of what we want to generate as a summary. And summarization on this regard is very interesting compared to other tasks where it's the content is preserved 100%. So in summarization, you have to decide what is important, what matters, what you want to generate or not, and what content you want to preserve, and what also other content you don't want because it's a summary. To that, so the first part to answer your question about the evaluation. You can generate all the possible questions in the source document. And you could imagine a summary. So even with the last method I've said, for instance, masking, this is a moment of Buckingham Palace. Given this closed form question, if in the evaluated summary, there's information that is present, the question answering system will find the answer. And so you can check if the evaluated text has this answer or not. That's the first thing. Now, how do you define if this question is important or not and is worth to be asked during the evaluation process? And I think I mentioned a waiter, but I didn't define how I trained it. And so actually the way I trained this waiter, you can see the waiter as the policy of what is important and not for this summarization task. In different contexts, it's not the same. And so here it's a trained waiter that I'm going to define. But in other cases, you could say, I'm just interesting about locations or whatever, and selecting only the where questions or the when questions. And so in this particular context, what we did is we have a huge training corpus of summaries and source document paired from Scialom email. What we took as a prior is we want a waiter that imitates the experts, the journalists, so that provide an innovation that fits Scialom email summaries. And so what we did is we generated questions on the source document, all the possible questions. Then we asked them on the ground truth written by human summary. For the question that has an answer there, we labelize these questions as important. For the questions that don't have answers in the human expert summary, we labelize them as not important. And so once you have these data sets, you can train a classifier to labelize automatically if a question is important or not. So for this particular point, we just train a classifier to imitate expert journalists about what is important or not in this particular context.
Yeah. I have one further question regarding multimodality, because you mentioned it like 30, and I think you mentioned it also with PhD, but you don't explain that.
Sorry?
You don't explain, you don't give, you say, I did it.
Yeah.
But, okay, it's short. And for example, in your introduction, you show the picture of your two dogs in the field and the caption. Okay, and when you see that, you have, if you adapt it with a summary and the image, if I understood correctly what you want to do with multimodality, you can have different meanings. It looks like you're looking for redundancy information. However, you also have complementary information. For example, for the two dogs, you can see the race, the colors, and it's not in the caption. So when you evaluate a model, how can you look at, is it complementary information that matters, redundancy, substitution, and whatever? You can have wrong information. That don't work. Whenever you talk about multimodality, you have to challenge.
Yeah, of course. First of all, I won't dig into the detail of how we train the models, but basically we just have a multimodal generator for questions and images, and the standard model to generate questions and caption or the text. And then we have a question answering system from the question we had from the image. We can ask them on the text. And from the question generated on the caption, we have a multimodal question answering system. We can ask them. From that, we can apply the quest-eval framework. And we develop the multimodal question answering generation systems with synthetic data and synthetic approaches. And we did the same actually for table caption, table to text. To answer your point, first, if you think about the caption as it, measuring only the factual consistency of the caption, it is enough already. You can generate all the questions in the caption, and for each of the token, basically, of the caption, you can check if the information is consistent with the. Why you're right is that for image captioning in particular, but that might be also true for other things like table captioning. You can have some information that are present in the image and not reported in the caption. This is actually kind of something related to summarization. And so we could imagine, but that's for future work, to develop some methods to leverage this complementary or to know what kind of questions are important or not to measure the recall of the caption. The same way we did for summarization.
Okay. I think for me, that's it. Sarah meant that she wanted maybe to ask further questions. Maybe not. So the tradition is that somebody that has a PhD in the room can ask a question, but only if you have a PhD. Maybe not. Okay, so now we're done now. Really? And we go for, we stay here or we go to